This is lesson 29 of the Quantum Mechanics mini lecture series. So in the last video, I left off with the basic form of a wave equation, something like this. Okay, y is equal to something. A is the amplitude of the wave. K is the wave number. X is the position of the wave along the x-axis. Omega is the angular frequency. T is the time, and this symbol here, phi, the Greek symbol, is the phase constant. This is like a general form of an equation. So in maths, whenever you get given something to plot, just draw up a table of values. So in this case, I've chosen x values 0, pi on 2, pi, 3 pi on 2, and 2 pi. I'm using radians, so pi on 2 is the same thing as 90 degrees. Pi is just 180 degrees. 3 pi on 2 is 270 degrees, and 2 pi is 360 degrees. So if you plug in 0 into this relation here, if we set a equals to 1, okay, we get 1, y is 1. Pi on 2 would get 0. For pi would get minus 1. 3 pi on 2 would get 0, and 2 pi is 1. So if we plot here, pi on 2, so this is 0. Let's call that the origin. Pi, 3 pi on 2, and then 2 pi. And on the y-axis, we'll go up by halves. Okay, half 1 minus a half 1. I should say minus 1. If you plot it, it looks something like this. Okay. Oops. If I go down like this. Okay, and similarly here for the negative x and y axes. So that's also known as a cosine, cos wave. Okay, it starts at 1. It's got an amplitude of 1, height of 1, up and down. And it intersects, it cuts the x-axis at pi on 2, so 90 degrees, and I should draw the line here, 270 degrees. Okay, that's like a general form of a wave. That's what a wave looks like in terms of the wave number. Okay, the spacing between the peaks tells you how far the peaks are. The angular frequency, okay, how quickly the wave completes one cycle, and the phase shift, okay, how far its initial starting point. That's a typical wave right there.